Hi, I'm Rich with insideHPC. We're here at ISC 2017 in Frankfurt, and I'm here with Rick from Lenovo at the Lenovo booth. Rick, welcome to Germany.
Thank you. You also welcome.
Yeah.
Very, very happy to be here.
Well, great. Thanks for having me. I think we should start at the beginning, Rick. Who is Lenovo, and who do you help?
Okay, Lenovo is one of the biggest, basically the biggest PC and server company in the world. Lenovo acquired the PC company from IBM many years ago, and 2.5 years ago, they also acquired the server group from IBM. So with that as a base, Lenovo has been making some serious growth within the enterprise server market, but certainly also over the last 2.5 years in high performance computing.
Okay. Well, I wanted to ask you about your new brand, which is the Think system. Yeah. What is that?
We're very proud of that. Yesterday we have announced the Think server globally in a big New York event. The European introduction was over here during ISC in Frankfurt. So we had a session yesterday evening with 150 customers and partners where we also replayed the video recordings of the New York event and where we introduced also the new brand. Okay. The new brand is basically a merger of the two existing brands within Lenovo. So the former Lenovo server brand and the former IBM X server brand merged into one new brand. And one of the things that we try to do is create uniformity in branding. So from a branding perspective, Think is something that everybody globally knows, from the ThinkPads, from the Think systems.
Yes.
So we have a Think system being servers now. Okay. So we're very, very, very happy with that new brand. Uniformity, simplicity, makes everybody's life easier, and we can share much more focused with our customers and our potential customers on the capabilities that we have.
Okay. So that follows. But what are you showcasing here at ISC, which is all about high performance computing?
Okay. So at ISC we are showing, to start with, our entire portfolio. We have a rack named Doris.
Okay.
Doris is being updated every year with all the new capabilities. This year it's showing all the capabilities that we have in our portfolio at the moment, including our HPC capabilities, which we ship to our customers and implement at our customers, called NextScale. So NextScale is the current Broadwell-based building block we use for high-performance computing solutions. Okay. We have this in two flavors, air-cooled and water-cooled. Specifically, initially, we started with that with LRZ, with SuperMOOC, where one of the requirements popped up that energy is going to be one big serious issue for everybody that wants to have a big data center and that needs a big data center. So any savings we can do on energy is a big deal. So it's not only savings from a financial perspective, it's also a carbon footprint perspective. So the machine that you see here, the water-cooled version, which we have standing over there, which I can show you also, is basically an efficiency at this moment already of over 85%. So the heat transfer, all the heat that's generated within the system, from the adapter cards, from the memory DIMMs, from the processors, 85% at least at this moment already is being absorbed by the water and fed away into free-to-air cooling capabilities on the roof of the building. So no chillers. You're not only saving energy on a server level, but you certainly are going to save serious spending on the fact that you can simply switch off a number of the chillers that you have for your air cooling location and that you would need for your air cooling capabilities.
So Rick, what do we have here?
What we have over here is the two generations of the water-cooled technology that we have been shipping for many years already. Some big customers and implementations. What used to be the biggest implementation in Europe and still the biggest water-cooled implementation in Europe with LRZ in Germany is basically based on this technology.
On this node here.
So what you see over here basically is one tray with two physical nodes. So in the length you have two nodes and you see two sockets. We've chosen, as Lenovo, for copper as a transport mechanism for the water because of the efficiency on heat transfer and efficiency of the flow rate. And the fact that contrary to aluminum, there's not going to happen any oxidation. So We've chosen copper because of the efficiency of heat transfer and the efficiency of the flow rate that you have to have in nodes like this. It has to be consistent in order to be able to transfer in a very granular way the heat from the processors, the memory DIMMs, the adapter cards that will be fitted in the front for the OPA and the EDR network connectivity. And in this version, it was still the drive at the back. So they have the heat of that has to be transferred very efficiently. So we have a water inlet temperature of 50 degrees in here, and the outlet temperature is going to be around 60 to 61 degrees. The water coming out is being typically transported to free air cooling capabilities within the customer premise and come back again at 50 degrees Celsius. So this is not chilled water, nothing is chilled here. So the consequence of this is that most of the chillers in a complex can be removed. And data centers that utilize this are data centers where you can walk in and talk to each other without having to yell to each other and without having to wear earplugs. So the only thing in those data centers still needing air cooling are the racks containing the spinning disks and the network switches. Cooling in that way is much more efficient. A lot of savings can be done. Reduction of carbon footprint is achieved, and big energy savings. And so this was the first generation as deployed at LRC. Then we have the current generation, which is this, where you see a difference on the copper tubing. To optimize the flow rate even better, what we've done is we don't have any soldering connections anymore within the pipes to make sure that you have efficient flow rates and to guarantee the efficient flow rate. So this is the current version. With the Think server announcement yesterday, we're also going to introduce a new version, a Pearly version of this one, which we at this moment for customers and for our customers that are interested can show already at the booth or at the location already in an NDA room after tight NDA signatures, because that is still very early days. It's going to be general available, the new one, in Q1 of 2018.
Good. Well, Rick, what else do you have that's new here on the show floor that might be, kind of cutting edge that maybe can't quite buy yet? What do you got going?
So from a news perspective, in the last couple of days there was a lot of noise about Barcelona Supercomputing and the Barcelona Supercomputing deployment of the new Pearly system. So it is globally the biggest Pearly deployment globally. So this was a tight collaboration with Intel to facilitate an early support program, which had a delivery of over 4,500 nodes before general availability and announcement even. Wow. Official announcement of Intel of the processors. So it was a very tight collaboration. It has been tested. We landed up at number 13 in the top 500.
Oh, you're talking about Mare Nostrum 4.
Mare Nostrum 4.
Okay.
And as it is, we have the nodes that we have used for Mare Nostrum. We have them on the booth over here. We can show you.
Oh, let's go take a look. Okay, Rick, what are we looking at here?
So what we're looking at here is the new 2U 4-node construct that we have delivered at Mare Nostrum in Barcelona as the building block for the new Mare Nostrum supercomputer.
Oh wow! This is Skylake then.
This is Skylake, and this is we call it the SD530. People that were more informed, we used to call this a Stark as a prototype. So it's the SD530 now. It's a 2U 4-socket node. And what we did with this platform is we disaggregated the piece and all the PCIe from the system board, and we moved PCIe requirements and capabilities to something at the back of the chassis. And that something at the back of the chassis is what you see over here.
Oh wow!
We call this a shuttle. So the shuttle has the cooling fans in here. So the cooling fans providing cooling capability to the adapter cards that you need in here, which can, to be honest, generate quite some heat, OPA adapters, EDR adapters, they generate a lot of heat, so you need good cooling facilities. On top of here, we can facilitate the 10 gig network connectivity, and there's one main choice you have to make with this shuttle when we're working with a customer. Do they require PCIe times 8 connectivity or PCIe times 16 connectivity? So every customer that has a need for 100 gig EDR or OPA has to go with the times 16. Backplane.
Okay. And this is modular, so when changes happen and new upgrades, you can just plug that into an existing node.
Exactly. We can slot them in and we can change it very, very rapidly and very easily.
Okay,
Yeah.
what's in the front end of it then?
So on the front end of it, you basically see the capabilities in the form of the potential 6 disk slots or 2 NVMe's and 4 disks. But you also see some monitor capabilities at the front, which are optional. So at the moment we're looking also at capabilities of front-end cabling this. And what you see is one of those slots will then be replaced by connecting capabilities for the network capabilities to provide EDR, OPA, or HDR connectivity later.
Okay. So this is 2 nodes and 2 sleds?
No, this is a 2U high, and it has 4 nodes.
4 nodes.
In it, so 4 nodes capability. So we have 1 node provided in here. So the consequence of moving PCIe away from the nodes also allowed us to make everything very dense and compact.
Very dense.
So this is what the node looks like. It is not deep. It is very light. It's very supportable, liftable, contrary to 1U or 2U servers, which you need a lift to remove from the rack. This is very flexible. Regretfully yet, I cannot open this one, because this one also contains Perly processors, which has not been announced. So we're not going to open this up. But there's 2 processor slots in here. 2 processor slots in here. There's memory DIMM slots in here, and there's already 3D crosspoint slots in here to facilitate the availability of 3D crosspoint support mid next year with the refresh that Intel's coming with.
So you're ready for crosspoint before even Intel is, sounds like.
We're ready before before availability of 3D crosspoint. Yeah, exactly.
Very nice. So Mayor Nordstrom is made up of a lot of, how many nodes?
It's about 4,500 nodes that build Mayor Nordstrom. And you know, it was already the most beautiful data center in the world.
A former church that they...
Exactly. And a lot of glass, a lot of shiny stuff in there, and it has, I dare to say, it has even improved again in beauty. It's really awesome if you see what has been delivered so early in the life cycle of Perly processors. It is really awesome if you see how nice it looks. And you know, from a performance perspective, it was also okay. So they ended up at place 13 at top 500. And you know, there's still some optimizations to go for. So that is not the end result from a performance perspective.
That's a very innovative architecture, and congratulations on that one.
Thanks very much.
I talked to Matteo yesterday, and he was just glowing about it. So great deal.
Overall, they're pretty happy with what they have had delivered, and it looks very nice. Again, you know, it is even the cabling. It is awesome when you have when you're building an HPC compute center and you realize that you want to show something really nice to your end users and to customers and to visitors, and you think about the colors that you want for your cables, and that you have different colors for different subnets of the network. You know, that is really a lot of attention has gone into detail for this opportunity of this engagement, and you know, it's been a real pleasure working there.
Great. Well, Rick, thanks for sharing that with us today. It sounds like Lenovo's future is very bright. You're going to continue to innovate. And
we've had a good track record since we've become Lenovo with our HPC developments. You know, growing from 2 systems in the top 500 to 92 now in 2.5 years.
Excellent.
A growth from 2 to 92, which is seriously awesome.
Almost 20% of the top 500.
It is. It's a big chunk. We're the second in the overall entries in the top 500. So starting from nothing 2.5 years ago, getting there in 2.5 years' time, we could only achieve that by having a real awesome team, and I'm proud of the team, both commercially and technical. It has been a big legacy coming from IBM, because most of the team has come from IBM with the divestiture of the X brand to Lenovo. I worked with IBM for almost 30 years before I joined Lenovo. And you know, it's been really eye-opening for me. It's been really entertaining, and it's really fun, and we all enjoy it.